Milan is here.
All right, so we're on to the next one here, the simple ceph-mon dm-crypt key management discussion for OSD, and yes, this wasn't Sam.
Yep.
It was
Patrick's fault.
I know. Most things usually are. Simulan here.
Yep.
Paging Dr. Braz.
Yep, I can start with the, I'll start by summarizing it, and Milan, you should make sure your mic works, I guess. Okay, so the basic status is that ceph-disk will configure dm-crypt for you. And when you put in a disk, it all sort of transparently starts up. But it's really kind of basic in that the dm-crypt key is just stored in Etsy ceph keys. So that's solves a piece of the problem in that you can take the individual OSD disk and throw it away and not worry about the data because it's obscured. But if you take the whole server, then you're still screwed because they have the keys on the same server on a different disk. So the goal here is to make a non-stupid key management scheme that's better than Etsy ceph keys. So there are like all kinds of crazy key management systems out there that you could potentially use to do this. I think the high level goal in my mind is to do something that uses a simple key manager. Ideally, that's just part of Ceph. We already have most of the infrastructure sort of built into the mon, but do it in a way that you could swap in a different key manager if you had some existing framework that you wanted to reuse for some reason. But for users who are just deploying Ceph, Ceph gives you sort of like a simple, lightweight, integrated key management thing already. So the pieces are that the monitor can already sort of store this arbitrary bits of key value data on the monitor via the ceph config set API. You can get and set keys, list keys, and you can restrict access to those keys to other, or to the, let's see if I can, you can restrict access to those key value pairs using different auth keys. So you could create an auth key that is only allowed to read sort of a prefix or a specific key from that config key store. I'm using the word key in like 12 different ways. Probably pretty confusing. So if we did this, then we could take the actual dm-crypt key, store it on the monitor in this config key storage section, and then have some other key that's allowed to fetch it and use it to configure dm-crypt and go from there. In reality, it's a slightly more complicated than that because we wouldn't actually want to store the key. We would use Lux, just the Linux something key system, which means that the key is actually stored encrypted on the disk itself in the special Lux metadata, and you have another key, password, let's call it a password, that lets you get that key that then decrypts the dm-crypt portion of the disk. Milan, are you there? Are you there now?
Hi, do you hear me?
Yes. Yep. Now I can hear.
Okay, so I'm here.
Okay. So we talked about this a little bit offline and on email, and now I'm trying to remember where we ended up. So your suggestion is to definitely use Lux to store the actual dm-crypt key. And if I remember correctly, you could also store other stuff in the Lux metadata portion, like a UUID or something else. Is that true?
Well, we cannot save any other data, but UUID is part of the Lux header, so that's probably the only thing we need. So that's the identifier of the disk, and we can pair it with anything we want. So UUID is there, and we can even set on UUID there is interface for that. So you can set something which is directly something similar you have for GPT partitions UUIDs.
Okay. So my assumption was always that you'd want something that's on the disk that's let's call it a password, the password that you then hand to the monitor, that the monitor says, oh, you're allowed to get the actual decryption key, that you then use to unlock the actual dm-crypt key that decrypts the disk. So there needs to be something that when the OSD is starting up, it presents to the monitor to tell the monitor that it's allowed to get the real key. And ideally, that something is something that you can revoke. So the monitor says, if that person comes along in the future, I'm no longer going to hand out that key because I know that disk was compromised or thrown away or something like that. So do you know what is normally used in that context? I'm not. There's probably a word for it, but like in a normal key management world, what's the thing that you show to the key manager that tells the key manager that they're allowed to give you all the keys?
Well, as I know, at least for example for installation, there is something called volume key, which is sent through key scroll. So it's key scroll packet where you can embed the key and send it to some other, usually some Active Directory or something like that. But I'm not sure we want to use that. So if you want something very simple, that's probably overkill. But you want to store the key just in plain on monitor or use some?
Yeah, I mean it's just a thing that identifies that the disk is allowed to get its decryption key, but that can be revoked.
So
right?
is there a reason to revoke it and not just delete the key?
Yeah, I think so, because you might think you lost the key, lost the disk, and then you get it back. Like maybe, oh, this PG can't peer, and I threw out the encryption key. I kind of want it back. Like I think it'd just be a little bit safer.
So you wouldn't actually do this, but hypothetically it could be something like on the monitor, it's encrypted twice, once with the disk's local revocable key and once with the master key, and you revoke it by deleting the one encrypted with the disk's local key. Is that the kind of situation you're talking about?
Yeah, I mean, at the situation, what I was imagining is slightly simpler. So you would say you had the ability to just store your your token password thing on the disk. You would identify it with the UID, and so that's like your token, and there would be n of those potentially that are allowed to get the real decryption key from the monitor. And so you would issue one to the disk when you create it that says, you, Mr. Disk, are allowed to get your key to decrypt yourself. And you could revoke that, and then later on you recover the disk and you would issue a new one, or maybe reuse the same one, I don't know. But if you revoke it, you could just delete that issued token. But if you are a super user on the monitor, you could still issue a new one, and you never actually delete the encryption key. Like I think deleting the actual decryption key for the disk seems dangerous. You generally don't want to do that.
Understood.
Well, wait, what's the goal for the revoking of the key? You just want to do something like data disposal, or
yeah. I mean, so if a disk goes missing, you want to, as soon as possible, revoke access to its decryption key.
When disk is missing, or when disk is still there, I want just to revoke it so it cannot be used anymore without any special operation. Because Lux allows to just delete all the key slots, so it's still Lux device, but without any key stored there. And you can, of course, if you have some key scroll or some backup of the key, you can unrevoke it, so you can install it again. But I'm not sure which case we are talking about. So when the disk is removed, and then you want to do something, or you want to just, for example, remove the keys from the disk and then, for example, send the disk for repair or something like that, so nobody can access it, even if there is unlocking key.
If I'm understanding this correctly, the thing Sage is suggesting actually replaces what Lux does. So Lux does the same thing, but it generates a random encryption key or something, which it uses to encrypt the disk, and then at predefined header points in the disk, it stores a Lux header that contains encrypted copies of that encryption key that are encrypted with the allowed decryption passwords, right?
Yeah.
But instead of putting that on the disk, you'd put this in the monitor instead. Or you wouldn't actually need to encrypt them because the monitor are trusted, right? So instead you'd simply use authentication to make a decision about whether the incoming token is allowed to read it or not.
Yeah.
It's not clear that Lux even adds anything there. except another chain that might, another link in the chain that might compromised.
Why do you want to replace the functionality of LUKS? I think you can just use that and just store the unlocking passwords or have some key hierarchy for unlocking. So I'm not sure.
You could do that. It's just that LUKS isn't getting you anything because you're
trying. Buy anything.
Well, it buys you a much less horrible interface to dm-crypt, which is true.
Well, there is quite, I hope, quite usable even Python library for managing LUKS. So actually, I was designing that. So I'm just asking why we don't want to use that.
Well, so the challenge is that once you've lost so there are two cases, right? In the case where you still have the disk and you're about to throw it away, then yeah, you can use LUKS to revoke its own key, and now the disk is unreadable. Score. But if you don't physically have the disk because it got stolen, you can't use LUKS to revoke the key because LUKS's headers are stored on the disk. It still doesn't necessarily do anything for the person who has the disk because they would need to have the decryption password. But if that's stored in Etsy and they stole the machine, then you have a problem. So you need to store the decryption password somewhere other than the server. And the point at which you're doing that is almost the point at which LUKS isn't buying you anything anyway, because you would never have two passwords in this situation to unlock the disk, because there'd be no point. You'd instead have two authenticated tokens that you can use to ask the monitor for the password. So it's more like having LUKS on the monitor instead of spread around the disk in headers. Yeah. This isn't to say that using LUKS is bad. It's just an additional layer of encryption. Or in addition,
I think we might as well use LUKS because it's sort of the standard thing.
And do you know that LUKS allows the detach header, so you can actually have the header on some different device and just manipulate with that. So
let you do that.
You can just have the metadata, the LUKS header can be just detached on another device in file actually. So.
Okay.
But I'm not sure you'd be able to. Could you factor it out so that you can have it make a call, a remote call to another server?
Yeah, of course. Well, then you don't need LUKS at all, and you can just use plain dm-crypt because you are basically degrading to plain dm-crypt.
Right.
Just
which is kind of
You might still want to use LUKS.
I think that's kind of where we are, my sense is that we can, or either we do or don't use LUKS, whichever is convenient and sort of makes users more comfortable, but it doesn't actually add or remove any capability here, right? By the way, so I think I don't think it matters either way. Either the thing that the monitor is holding in escrow is the password to decrypt the LUKS key, or it is the actual disk encryption key, and I think it doesn't matter either way. But actually, it might be slightly safer to store the actual encryption key because it means that somebody couldn't accidentally screw up the LUKS header or something and destroy the key inadvertently or render it inaccessible.
That's true.
They can't destroy the whole disk without sort of order in destroying. Well, I don't.
You can still hit whatever the file system equivalent is.
Yeah. Okay.
On the other hand, there are two versions. So LUKS does its own hashing and salting to generate to go from the password to the key. So it might be the case that either that adds strength because it papers over problems with weak passwords, which doesn't matter for us because we'd be randomly generating them, or it removes strength by adding another weak point in the chain. So I don't know.
Yeah. I think this is sort of a red herring. So I think that the real issue is there needs to be the thing that you present to the monitor that says you're allowed to get the key that can be revoked. And that needs to go somewhere. So if LUKS has a UID that you can set, then it just so happens that UIDs are 16 bytes, right? And the AES ceph-x keys are also 16 bytes once they're U encoded and all the metadata is padded on them. That's kind of a hack, but you could conceivably do that. But it would be nicer if there was just...
Not quite.
So there needs to be a thing on the disk that says I'm the revocable thing that I present to the monitor, that the monitor then says, oh, here's your decryption key.
Interesting. You could just present its own cephx authentication credentials.
Right. So the way that the monitor, yeah, right. So cephx lets you set an auth capability that lets you access like a specific key. For example, the decryption key for dm-crypt.
But every OSD separately already has a separate cephx key,
which
right?
is stored encrypted in the OSD directory on top of the block device that dm-crypt is encrypted. Yeah. So this is the thing on the outside.
Yep.
Right. So Lux might provide a convenient place. The Lux metadata area might be a convenient place to just stash that thing that we can set. I mean, it's 16 bytes is the actual key, but once you pad it out with all the other stuff that's in the entity key structure, it's like, or crypto key structure, it's probably 30 bytes or something. And it usually gets base 64 encoded, so there's a little string. But we just need to put that somewhere, basically. Does this make sense, Milan?
Actually, I'm not sure if I fully understand what you want to store in UID now, but whatever.
So I mean, there needs to be the key, the password, the something, the token, whatever you want to call it, that you present to the monitor or some other key management system. That
okay, why
give you the key?
Yes, I understand that, but why it cannot be just some random or some UID with some prefix, which is just index or something which is sent to monitor, and monitor will just search if it's coming from the proper OSD and has the key paired with this UID and send that key to the
So you're asking
machine.
Why not simply use the hard disk's own UUID?
Yes, just as index for the key on monitor.
Well, that one's comparatively public, right? You don't really want other OSDs or other things to easily be able to see it. You'd rather it were secret.
It needs to be secret. Yeah.
I think it's will be sent encrypted to monitor by some session key or something like that. So why it's public or
yeah, but any process on a machine can read the /dev/by UUID thing and get those UUIDs. That's not secret, right?
Well, yes, that's not secret, but you can pair it with some identifier or some key for the OSD. So still you can generate something, and you.
Yeah,
I think apparently something here, but well,
it sounds like you're assuming that there's some like host level authentication, so you know that this particular server is allowed to be presenting it. So that, like the way that the key management controls access to the key is using this secret, right? It's not host based. It's not anything else. There's a secret that you present to the monitor that says I'm allowed to get the decryption key.
But the connection to the monitor is already authenticated, so just a random process.
Authenticated with this key. This is the key that you authenticate with the monitor with. That's the thing. There's no host level. Well, there needs to be something, right? So when assuming everything's decrypted and you're starting up, the OSD authenticates with its key that it stores inside the file system, for example. If you're an admin, you authenticate with the key that's in etsy ceph keyring. But when you are an encrypted disk, in order to get your decryption key, you need to authenticate with something, right? It's not. There's no like global host property that says that. We could make one. I guess that's another option. Like you could say that any disk that appears on this host is allowed to get access to the key, but then that doesn't work because then the host would have to be able to access any OSD, right? And if a single compromised OSD can get decryption keys for any other disk in the entire system, that's a big vulnerability. Like you want to narrow the scope as much as possible. So
well, you have a problem there anyway, right? Because if you store that key in Lux, then it's either stored plain text or it has a password, right?
Yeah, it would have to be plain text because it needs to.
Yeah, that's right. So any
Right.
process
So
on the machine that can, but you'd have to actually have the disk. So I guess that's
Yeah.
something. Okay.
Right. So the two things that you need are access to the network, so you can talk to the monitor, and the disk. Right. And if you only have the disk, but you're not on the network, like you walked into the data center and yanked it and walked out, then you have nothing. If somebody actually gets into the data center and they have both the disk and they're like connected to the machine and they have root, then obviously all bets are off because they can do everything that the disk can do to mount itself to decrypt it. And then, right. So that's
well, in that
that's
case, you might as well just pass the disk's UUID.
It just has to be something that isn't publicly shared beyond that host. Like it has to be something that you can look at in dev whatever, but it I think the UID on the partition is the OSD UID that's also in the OSD map.
Oh, okay.
I think. I'm not certain about that, but I think that's the case. So it'd be nice if there was just a separate space that's, I mean, maybe, okay, so that's possibility one. Maybe that would just work. Maybe the GPT label UID can be used as the key. Make sure it's not shared beyond the host. I'm afraid it might be though. That's a problem because there's this FSID.
Oh, because it might be in the, okay. Yeah, sorry. I understand now.
I'm not sure if that matches the partition label UID matches the actual internal OSD UID.
Okay. And if it is, then you just generate a different appropriately sized number and stick it in the Lux area. Yeah, okay. That makes sense.
Yeah,
so the question is,
Lux has already a UID. It's 40 chars long or something like that. At least the header has the space for that. So
is it specifically a UID or is it just a 40 character string that I can
40 character UUID. I don't know. Like the spec says it's a UID.
UID universally unique ID that is not a UUID. Okay.
Yeah, that's annoying.
Well, can I have a question? The UID you are talking about, or whatever UID, either it's GPT partition UID or Lux ID, it's not secret for other processes. It's actually UDEF parses it, and you can see it clearly in def UID, disk by UID. So whatever. So I think you cannot use that as some secret key.
Well, it would be. I think we've come to the conclusion that it's not a secret key. It needs to be a key that you have as long as you're physically holding the disk, or at the machine where the disk is plugged in, but not one that you have if you're simply observing the cluster from somewhere else.
Well, it can be if it's stored on the device and not part of the GPT data, then only root can see it, right? Can only root
or that. But I mean,
yeah, which is better. So probably
it is better.
Yeah.
Well, if you are root, you can if you have activated dm-crypt device, you can directly get the encryption key anyway.
Exactly. Exactly. Right. So I think something that only root on the host with the disk can access is, I think, the ideal situation because that's when you're already screwed. So if that's the case, then if there's somewhere in the Lux header where we can store something that only root can get at, that isn't parsed by UDEV and put in sys. Or
I don't think you can, because if there is a header which is available or the disk is readable for other user, you just cannot hide it. You can either need to encrypt it with another key or it's just public. So
right. So I guess the assumption is that anyone who has permissions to read the disk can see the key, and that's just the way it goes.
Yeah,
but anyone who doesn't wouldn't be able to see the key. So that would at least stop. Well, something probably.
Yes. Yeah.
The UID of the disk is not the same as the OSD UID.
Is that a question or a statement? I can't remember.
The question. That's the question.
Yeah, I can't remember.
Doing? if it's the same, then you can simply get a list of UIDs from
the OSD map.
From the mon.
Right. So if that's the case, we can't. Then
exactly.
Yeah, then you have it. So that's
But even if it's different, then any non-root user on the system can also see all the UIDs because they're in dev disk. So ideally, it would be something that's just stored in a random sector on the disk, or something else that requires somebody to actually be able to read the raw block device in order to read it. So I mean, maybe the Lux does the. Oh, hey Milan. So the Lux header lets you store like any arbitrary key as long as you have a password, right? It's not specific. It's just a little lockbox. Is that right?
Logs header has two different parts. First part is visible header, which is passed by block ID and so on. There is the UID stored and some visible parameters for encryption. And then there are key slots. There are actually 8 key slots, and they are encrypted, and it actually contains the real encryption key. So
okay. So maybe the thing to do here is actually to use one of those slots to store the key to talk to the monitor, and then use a sort of a well-known password to decrypt it. So maybe your ceph.conf says the Lux lockbox password is, my cluster. And so you'd use that to get the Lux.
That's something which is not possible with current version, because if you have enabled key slot, only the encryption key can be stored there for current version, because the part of the unlocking is that there is some kind of checksum. So you enter a password, it will iterate, it will decrypt that, and it will check if the decrypted key is correct. If not correct, it will just fail. So you cannot store anything there just randomly. So I would like to have new version of Lux where this is possible, but for current version it is not possible. So
so it's not a lockbox. It's only useful for storing the key. Okay.
So there has to be a dm-crypt partition that uses that key on the same device. Is that what you're saying?
Well,
I'm confused because you said you can also put the Lux thing, the Lux metadata on a different device, right? Like we're still storing a key. It's just a different kind of key.
Well, it sounds like the interface just doesn't let you do that.
We can use detached header and different detached header and store something there. That's possible, but that could be done. You can have just file or some different partition just with the Lux header and store something in key slot. But it seems to me like overcomplicated here. Isn't that just
if it has to be a different header, then we don't gain anything, right?
Well, okay, no. Let's see. So the process would be that in the ceph.conf would have Lux secret equals foo. 2, you'd use foo to unlock on key, call it bar. 3, ceph config key get ... with dash key bar. 4, then you would use start dm-crypt via Lux using Baz. So that has the added benefit that you not only need the disk and access to the network so you can talk to them on, and you need to know what was in ceph.conf, which was on a different disk in the same system, which also seems kind of nice. That makes sense?
So the secret of the key is stored in ceph-conf.
This is the key that's just enough to get the ceph monitor key out of the Lux.
Yeah,
so to authenticate with the monitor to get the real decryption key, or not the decryption key, but the
It's something like authentication token to monitor, or how to say
exactly.
That.
Yes.
Yeah. Well, that's a very simple solution, but why not?
So Baz, which unlocks real dm-crypt key, hides that from you, or crypt setup does, or whatever. Does that make sense to you, Danny?
Yeah, the only thing I'm thinking about is how is the actual key in the monitor stored?
Okay, so on the mon,
is it crypted or what? Is it? It's on the file. I mean, in the end, somewhere on the file system. And
you'd have like OSD.3 dash lux equals Baz. This would be the actual key value that's in there, and then you would also have OS3.3 dash lux dash token equals be the key value, and then you would have an auth user, client dot lux OSD.3, which has key equal to R, and mon equals allow config key prefix.
Yeah, that's somehow clear to me. The question is how is the data stored, the real data?
Yes. So is that actually
on the mon? I mean,
yeah.
Is there a reason not to just store it in plain text?
I mean, it's already in. It's the plain text thing that you give to Lux on the disk to decrypt the real key. Yeah, I guess that's my yeah. So Milan brought this up too. Like, is there a reason not to just store that plain text? I guess.
Yeah, I guess that's the point.
You need to have both it and the you need to have both it and the disk to do anything, and
Right.
also the monitor isn't going to use different encryption keys for each one of these, or if it does, they'll be generated. So, or they'd have to be stored in the same database. I don't know that there's any real value in. It's not like we'd put the encryption key somewhere else and have a separate authentication thing where it then passes off the same information to some other authentication manager, which then passes back the decryption key for this key.
And even if you fetched like all of them today, and then 3 weeks on the line you got the disk, like yes, you can put the two together, but you could. The only thing that prevents that is that you would rotate them, and this actually has everything that we need to rotate it because Baz can be changed to Baz2, and the Lux thing can also be updated to use Baz2. Right.
Yep. Yeah,
but if you just then you can do it.
Rotating doesn't help because you can brute force it, or do you mean with rotating generate new and revoke the old one?
Just generate a completely random,
new key.
32 bytes of right. You could do that. I think in reality nobody probably would do that, but you could. If you were worried that somebody dumped a copy of all of the stuff on the monitor, and at some future date they might steal a disk, then you could go through and rotate all these, and you would be protected again.
Yeah, I mean, the other problem would be to steal the disk and the data from Ramon at the same date, and then.
Yeah, but
I mean, at that point, they could have simply.
I mean, is there any way to crypt it in some way to not have a plain text there? So.
Well, that's the point. How could you create, or how could you encrypt it in a way that where the monitor didn't also have access to the decryption key?
Yeah.
Or the disk didn't have access to the decryption key, right?
Yeah.
Like if you encrypted it with something, then the disk has to be able to decrypt it. In which case, you already need the key and the still the same number of things you need to compromise on.
It would be cool to have something that you can plug in this place to use a different key distributions.
It would be the same
something
problem,
like
though, whatever the.
If, for example, if you use Barbican or something like that in an OpenStack context, then you have at least a separated system that is not part of Ceph itself, so it's maybe more secure. It's at least
it would be easy enough.
Kind of separation.
It would be easy enough to make this pluggable, right? Just whatever you store in Lux is uninterpreted, and something from the ceph.conf tells you where to get your key and what plugin to use to do it.
Yeah. More in ceph.disk, it's going to make these, the ceph call, ceph config key get, and that could instead do, my key manager, get key, ... right?
Yeah. Yeah, okay.
So, Milan, do you still have concerns? Is there a category problem this isn't solving?
Well, I don't like storing any key in plain, but here it's probably the simplest way, and I expect that in some corporate configuration it will be replaced by some real key storage, like something. So we should probably have it as some real plugin interface. So instead of storing key here in plain, you just call some key management system or something like that.
Okay, I guess there's one virtue to storing it not in plain text. You could present the decryption key to the monitor on startup, and it could not record it.
What I would
that would at least encrypt it at rest, I suppose.
You can have some encrypted key storage and just populate on the start. You have to decrypt it somehow, so still have some key, but populate it to some keyring, like kernel keyring or so, where it basically is designed for storing the key when running the system. But for simplicity, I think that the first implementation probably should be, as mentioned here, but the problem with storing key in plain text in files is that you never know where it's copied when file system is doing something. You can manipulate it with that, so you can have many copies in some sectors. So that's the problem with storing the key in plain.
But I mean, it still feels like it depends on what you're defining as the key, because this isn't the key. This is the key to decrypt the key. Right, the actual key is stored in Lux. So you could encrypt this, but then somewhere there's the key to decrypt the other key to decrypt.
Well, it seems to me that the only advantage to encrypting the key is the specific case where you've lost the mon disk, but they don't have access to the mon to some other piece of mon configuration. So you could provide the monitor with the decryption key for all of these things at startup, which it just uses and doesn't write down, and that way, at least if you lose the disk, right? But I think that's the only thing it buys you.
Yeah, I think that if you get them on, and if you get the key escrow system, and you get the thing it's managing, then you're screwed no matter what, right?
And you can always run them on an encrypted block partition anyway, which if you want to throw it away, you're probably going to do.
Yeah.
Or if you want to be able to throw away the disk, that's probably what you're going to do.
Yeah.
I mean, the question is how real is the scenario that somebody is stealing a disk from a real data center? I mean,
that's
how often will that happen? I mean, the most interesting, at least from our side, the most interesting part would be the issue to dispose disks. I mean,
yeah. Well, that's already solved today, right? Yeah. You can just rip individual disks out, and the root partition has.
Yeah.
But
if you dispose a complete server, then yes,
exactly.
It's the issue.
I mean the scenario that I seem to hear is that you have the disgruntled employee who just pulls a machine out of the rack in the data center and walks out the door or something like that.
Yeah. But then
that disgruntled employee could probably.
Could do a lot of stuff, yeah.
Probably grab the keys on his way out too.
Or maybe I guess it's more likely to be the data center employee who goes into your cage and pulls out your server. They don't have access to the systems, but they can just walk off the hardware.
Yeah, but then he has a problem to reconstruct the Ceph stuff. I mean, what does he have then? He has Raiders objects, so yeah.
Yes.
Make something out of it, out of one server or two or whatever.
Yeah.
Well, to be fair, I mean, what you have is a random. You can just grep out various patterns, and you could get.
You can.
Yeah. I think that's the typical scenario, right, where people.
And crypt also your RSproc devices too. Then you don't have that problem. But yeah, correct.
All right. Okay. Well, we're over. We've probably beaten this horse.
The next one's going to be very short, so if there actually is more stuff to talk about, that's fine.
Yeah. Okay.
Sounds like a whole lot.
You know what? Actually, you know what? There is one big thing here, and that is that the session between a client on the CLI and the monitor is secure in when they negotiate, and they negotiate a session key that doesn't reveal any secrets between the two. But thereafter, once you're authenticated, the actual commands that go back and forth are sent plain text over the wire. So I think in order to sort of complete this picture, we need to have some simple encryption that uses, we already have a session key that just does AES or whatever on the actual bytes that go over the wire. Maybe when there's a special option so that you're only doing this when you're talking to the monitor from the CLI or whatever. Maybe there's like a ceph -- encrypt session ... or something that enables this. So that when you're, for example, installing authentication keys, you're not actually sending the keys that you're installing plain text over the network. Just sort of a current thing that a few people have noticed, but we should probably fix. That means in simple messenger, option to encrypt the actual messages sent over the wire based on the existing. And I think it's pretty simple. We already have all the. It just means like calling AES encrypt on the buffer list before we send it over the wire. Like it could even be just everything after the header. So like, and header plain text. Maybe it just does everything. I don't know. Yeah, I don't know. Whatever. We have to figure out how to layer it in, but. Okay.
Good on that one?
I think so. By the way, Danny, your video is frozen. If you click and unclick your video button, it'll.
No,
frozen for me.
Oh, it's not? Oh, it's my phone.
Nope.